Hello friends, yeah, welcome back to my YouTube channel. So today in mathematics I'm going to be looking at how to differentiate this kind of function. This is very interesting. So looking at this question, I have these two functions. So I'm going to apply product rule here. It says perform the following derivative. Y is equal to 2 exponent x times x exponent 2. You can see there are two functions. So one is actually easier to differentiate, but the other one is not that easy. So this is very interesting. So in this case, to find the derivative of this expression, I'm going to find, first of all, apply product rule, okay, because the function or the expression is the product of two functions. So that means I'm going to apply product rule in order to differentiate the expression. So, and you know that product rule is, okay, but before that, one important thing is to know that I'm going to take uh, 2 exponent x to be equal to a and take x raised to the power of 2 to be equal to b. Okay, I'm going to give them a and b now, so that if I'm using product rule, I'm going to say that because you know that product rule is the y over the x is equal to, so I'm going to say a, that is 2 exponent x multiplied by b prime. B prime is the derivative of x exponent 2. Then plus b times a prime. A prime is the product of, the derivative of a. But to find the derivative of a is not that easy. I'm going to do some work there. So that is, this formula is the product rule of differentiation. But before I apply this, I'm going to bring out a is equal to 2 exponent x. So I'm going to look for the derivative, I'm going to find the derivative of a so that it will be easy to use in this formula. So in this case, first of all, I have to find a way to eliminate the exponent, which is x. Because ordinarily it should be x raised to the power of 2, but here it is 2 raised to the power of x, so upside down. So what I need to do is to take logarithm, natural logarithm, that is length of both sides of the equation. Then a is equal to ln 2 exponent x. Because you know, when I cancel ln, I'm going to get a is equal to 2 exponent x back. Now, this is the first thing to do. Taking logarithm, natural logarithm of both sides of the equation. So the next thing to do is to take the logarithm to base e, okay, of both sides again. So when I take e here, I'm going to take another e here. So you can see ln will actually cancel e. That is the law. When you have base natural logarithm to base e, then length is exponent, they will cancel out. So I'll still get a back. A is equal to ln, e raised to the power of ln 2 raised to the power of x. Okay, but you know that if I apply power law here, this 2 raised to the power of x, because you know that when I got this, initially um, when I got ln, a is equal to ln 2 raised to the power of x. Okay, so I can say that because if I apply power law of logarithm, this x is going to multiply ln. So now I will have ln a is equal to x ln a. So it's still the same thing here. I can still say that, okay, a is equal to e raised to the power of x ln 2. So it's still the same thing. So in this case now, it means that a is equal to e raised to the power of x ln 2. That is the law. Okay, so I'm gonna write that a is equal to e raised to the power of x ln 2. So, and you know that it's the same thing as 2 raised to the power of x, because we derived it, we actually got e raised to the power of x ln 2 from 2 exponent x using natural logarithm. Okay, but that is not the answer. Okay, so from here we can find the derivative of a, that's a prime. Okay, to get the derivative of a as a prime, I'm gonna say differentiating this expression now. Okay, I'm gonna have a prime, that's a prime will be equal to, so differentiating this expression here, that's e raised to the power of x ln 2. So there's a formula I'm gonna apply. I'm gonna use this formula. There's a formula like this: d over dx is equal to or rather e raised to the power of ax. So when I differentiate this is equal to, I'll multiply the equations of x, which is a, by e exponent ax. This is how to differentiate this kind of expression. So I'm going to apply it here to find a prime. So finding a prime here, I'm going to have ln 2 e raised to the power of x ln 2. That is the derivative, that is a prime. So I'm going to use this a prime now here in this product rule. So this a prime, so this is the a prime. Okay, so it's very important to remember ln 2 times e raised to the power of x ln 2. That is the a prime, that's the derivative of a. So that's why I said that it's not easy. We have to do some work. You have to get the value of the you get the derivative of 2 raised to the power of x, and this is what it is now. This is what it is. Then 2 e raised to the power of x then 2. So before we now apply the product rule, so the product rule, which is a times b prime plus b times a prime. So that is what I'm going to do. So in this case, a is, remember that we got a, our a is this. Okay, so we may decide to take this as a is equal to e raised to the power of x ln 2. And you know, this is the same thing as x raised to the power of 2. Sorry, 2 raised to the power of x, rather. As this is the same thing as 2 raised to the power of x. So in this case, in this formula, I'm going to say dy over the x, okay, will be equal to, so I'm going to write our a is e raised to the power of x ln 2, okay, times our b prime. So what is our b prime? To get b prime is very easy. X raised to the power of 2. The derivative of x raised to the power, this is our b. This is our b, which is x raised to the power of 2. To get the prime, this is our b. To get the prime, that is b prime, is equal, it will equal to, we'll just say 2 times x. That is multiplying the, using the general formula of differentiation, which is this, ax nax raised to the power of n minus 1. So, and n is the coefficient, is the exponent, that is the power. So I'm going to say 2 times x will give me 2x. Okay. And 2 minus 1 is going to give me 1. So the derivative of b, that is b prime, is 2x. Okay. So coming here, I'm going to say times. So I'm keeping, this is the value of our a, e raised to the power of x ln 2. That's the value. Then multiply by b prime. B prime is 2x. Okay, that is it, 2x. Then plus, okay, so in this case I'm gonna, since I kept in A, the product rule says A times B prime plus B times A prime, so I'm gonna keep B, which is x raised to the power of 2, then I'll multiply it by the derivative of x raised to the power of 2. So this is the derivative of A prime, that is this. This is the derivative, which is ln 2 e raised to the power of x ln 2. So I'm going to write ln 2 e raised to the power of x ln 2. Okay, this is the derivative. So in this case, I'm going to simplify this. Okay, so dy over dx is equal to, so looking at this expression, I can factorize, I can bring out e raised to the power of x ln 2 out of the bracket, and I'll put bracket here and write 2x plus x squared, okay, ln 2. So this is what it is when I factorize it. Okay, now, and you know that e raised to the power of x ln 2 is the same thing as x raised to power 2 raised to power of x. Look at this. Look at this place. Look at this place. Okay, so I can decide to replace e raised to the power of x ln 2 with x raised to the power of, or 2 raised to the power of x. So then I will have dy over dx. Dy over dx will be equal to 2 raised to the power of x bracket 2x plus x squared ln 2. Okay, I'll just do it like this. So looking at this, I can still factorize because x is here, this is 2x, and this is x squared ln 2. So I'm going to bring out one x again. I will have, so dy over dx is equal to x will come outside, and I'll have 2 raised to the power of x again, plus bracket 2 will remain here, plus 1x will remain here, then I'll have ln 2. So in this case, this is the answer. The derivative will be dy over dx is equal to x times 2 exponent x in brackets 2 plus x ln 2. This becomes the final answer. Thank you for watching. Don't forget to subscribe to this channel for more.